Good morning, my dear students. Today we will delve into the interesting topic of arithmetic progression. In this chapter, we will explore various aspects and number series related to arithmetic progression. However, before we begin, let's take a moment to review the previous chapter we have covered. In chapter 1, we have covered real numbers, which form the foundation of mathematics and include rational and irrational numbers. In chapter 2, we focused on polynomials, where we learned about expression with multiple terms and their operations. Moving on to chapter 3, we explored many things related to linear equation into variables. We studied how to solve system of equation and understand their graphical representation. Understand their graphical representation. Now in the chapter 4, we tackled quadratic equation, which involves variable raised to the power of 2. We learned different methods to solve quadratic equation, including factoring, completing the square, and using the quadratic formula. Now we have reached at chapter 5, which is all about arithmetic progression. This chapter promises to be exciting and intriguing. To fully grasp the concept and techniques involved, I recommended watching the related video playlist. It will greatly aid in your understanding and overall development. So, let's embark on our journey into the world of arithmetic progression and uncover its fascinating concepts together. Now, if we talk about the introduction of this chapter, you should look this picture. This picture is of collection of squares, and this picture is collection of circles. Now, here area of square is 500 meter square, 400 meter square, 300 meter square, 200 meter square, and 100 meter square. Clear? Here, this is here radius is 2 meter, 4 meter, 6 meter, and 8 meter. Radius of the circle. Now, we should observe on the figure. This figure tells us something more, which is related to arithmetic progression. Here, area of square is decreasing, but with a definite number, a certain common difference. Here, difference between two is 100. These two 100. This is fixed 100 and 100. Now in the figure circle we get difference 2. between two circles. There are two difference in radius. Then these differences are common. These differences are common. You must have observed in the nature many things follow a certain pattern. Just a certain pattern. Many things follow a certain pattern, such as the petals of sunflower, the holes of honeycomb. If you try to look at apartment of house and home, you will get a clear cut pattern. All are the same, but some is small, some and big. There are many rooms in classroom, in school. You will get same structure, same pattern. In our day-to-day life. Clear? That things comes under arithmetic progression. Here examples of progression. Do you know the natural numbers 1, 2, 3, 4, 5, 6 and so on? Even numbers 2, 4, 6, 8, 10, 12. The multiple of 3, 3, 6, 9, 12, 15, 18. The first 10 positive integers that are not divisible by 3, 1, 2, 4, 5, 7, 8. Clear? Observe these patterns. Here differences between two quantities, two numbers is 1. Clear? Here differences between two. Here 3. Differences between two numbers. Here differences 1, 2, 1, 2, 1, 2. Some differences 1 and some differences 2. If we exclude 1, we get 2. If we exclude 2, we get 1. So when we observe, we get a certain patterns of increasing, certain patterns of decreasing. These series, these sequence, these pattern say some things about behavior. So we can define the definition of arithmetic. And arithmetic progression is a sequence of numbers where each term is obtained by adding a fixed number, known as the common difference to the preceding term. The common difference can be positive, negative, or even zero. Here we have learned many things. Here the differences, common differences is 1, common difference 2, common difference 3. Common differences are 1 and 2 here. So common difference can be 0 and positive and negative. Clear? Let's consider the sequence we already discussed. Do you know The arithmetic progression is a sequence of numbers such that difference between any two consecutive terms is constant. This constant difference is called common difference of the AP. Between two numbers there is a difference which is common. If we subtract from is if we subtract from second from 1, and that means next minus before, we get different common difference D. So AP can be finite, infinite, such that this table, first term A, second term A plus D, A plus 2D, A plus 3D, then common difference is D. Finite, if this sequence is finite, then has a last term. If this is infinite, does not have a last term. Clear? Now we should follow some examples of finite AP. What? If it is finite, then it has last number. Here last is 18, here last is 13, here last is 17. But differences is 4, 3, 4. 6 minus 2 is 4, 10 minus 6 is 4, 14 minus 10 is 4. So common difference is same, that is 4. If we subtract 13 minus 10, we get 3. 10 minus 7, we get 3. 7 minus 4, we get 3. 4 minus 1, we get 3. So common difference is 3. Now if we subtract 17 minus 13, we get 4. 13 minus 9, we get 4. 5 minus 1, we get 4. So these are the common differences of finite AP, where last term is known and fixed. Examples of infinite where doesn't have last term. So but common difference will be same. 2 minus 1, we get 1. 3 minus 2, we get 1. 4 minus 3, we get 1. 5 minus 1, 5 minus 4, we get 1. In this same way we can get common differences. Clear? So we can say that in general AP A1, A2 up to AN, we have common difference of K plus 1 term minus K term. Now if the series A1, A2, A3 up to AK plus 1, AK up to AN, then common difference will be AK plus 1 term minus AK term. AK plus 1 minus AK. That is the common difference. Clear? So A2 minus 1, A2 minus A1 will be common difference. A3 minus A2 will be a common difference. In same way, AN minus AN minus 1 will be a common difference. So we have discussed the introduction part and many things. Do you know, in the same manner If you got a selection and maybe you have been offered a job with a starting month salary 8,000. Clear? 8,000. With an annual increment of 500 in her salary, with an annual increment of 500 in your salary will be in first year 8,000, in second year 8,000, 8k plus 500. Clear? Then 9k, then 9k plus 500, then 10k. Clear? First year, second year, third year, fourth year, fifth year, that will be. So it is also useful to understand arithmetic progression. Now we should solve exercise 5.1, which will give a clear understanding related arithmetic progression. First question is that in which of the following situations does the list of numbers involved make an arithmetic progression and why? Clear? The taxi fare. The taxi fare after each kilometer when the fare is 15 for the first kilometer and 8 rupees for the additional kilometer. That means A1 is given here. First is 15, then 15 plus 8, then 15 plus 2 times 8, 2 times 8, and so on. Here first is 15, second will be 23, and third will be 31, and fourth will be 39. Clear? These has difference 8. If we subtract 31 minus 23, we get 8, and here we get 8. So common difference CD is 8, and we get 15 as a first term. So A1 is 15. Here it is A1, it is A2, it is A3, A4, and so on. These difference between successive terms are same. So we can say that given question and given pattern is an AP. So it is an AP. Now next question. The amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. Clear? The amount of air present in a cylinder. So let amount of air present in cylinder is x. Clear? Then here is a term A1, A2, A3, A4. A1 is x, we assume, and A2 will be here when a vacuum pump removes 1 by 4th of air remaining in the cylinder at a time. Then A2 will be x minus 1 by 4 of x. Clear? In second, because air is remaining, so first was x in present, and after 1 by 4th of the air is removed, so we get x minus 1 by 4 of x. Clear? It will be 3 by 4 x. Then again 3 by 4x, that is that will be the present air, but 1 by 4 we will subtract, we get 2 by 4. Okay, here 1 by 4th of 3 by 4 x. Clear? We get this is first term, this is second term, this is the third situation. We get here 4, so we should rearrange it 3 by 4 into 4 into 4 minus 1 by 4 into 3 by 4, take common of x. We get 4 4 ja, clear? 4 4 ja 16. Then we will get 3 4 ja 12. 12 minus 3. 12 minus 3 will be 9. Clear? Then in same pattern 9 by 16 x minus 1 by 4 of 9 by 16 x. This will be, if we common 9 by 16 x, we get 1 minus 1 by 4. So 4 minus 1 will be 3. 9 by 16 into 3 by 4 x. Clear? That will be 27 x by 64. Clear? Here differences are not same, because now here is x. If we subtract this, we will get 1 by 4 x. And if we subtract this from this, 4 4 just 16. Now in next slide, first term was x A1 was x, A2 is 9 by 16 x. Then difference of these 9 by 16 x minus x, that will be minus 7 x by 16. No. First term was x and second term was, this is A3 and A2 was 354x, 3 by 4x. Then difference will be A2 minus A1 equal to 3 by 4 x minus x, that will be 4 minus 3 minus 1 by 4 x. Now A3 minus A2, A3 is 9 by 16 x, 3 by 4 x, we will get 4 4 is 16, 4 3 is 12, 9 minus 12, 9 minus 12, 3 by 16 minus 3 by 16x. So the difference this and difference this, these common difference d is not equal. That means common difference CD are not same. So it is not, if it not same, so it is not an AP. It is not an AP, arithmetic progression. Okay. Now in third question, the cost of digging a well after every meter of digging, when it costs of 150 rupees for the first meter and raises by 50 rupees for each subsequent meter. Do you know? A1 is given 150 rupees. Clear? Then A2 is given next digging will be 150 plus 50, that will be 200, and A3 200 plus 50 will be 250 rupees. Clear? Now A4 will be 250 plus 50, then it will be 300 rupees. Okay, and so on. We are getting the same common difference between this. The difference is 50. The difference 250 minus 200, it will be 50, and 300 minus 250, it will be 50. Clear? So common differences are same. If common differences are same, then it is an AP. Clear? Now fourth question. The amount of money in the account every year. When 10,000 is deposited at compound interest at 8% per annum, given rate R is 8%. Clear? Principal value. Principal value we will denote at P. It is 10,000. Clear? So it will be A1. Now, for second year, the amount will be A2. It will be the 8% compound interest of 10,000 of first term. So, according to formula, it will be P into A equal to P into 1 plus R upon 100 power n. N will be number of times. So, here P will be 10,000. Clear? Here P will be 10,000. Then 1 plus rate is given 8 by 100 and number times 1. 100 1 is 100, 100 plus 8 by 100. Then into 108 by 100. After solving this, we will get 108, 108 and 2 times 0. 10,800. Then A3 will be, because this is a compound interest, then next interest will become on nearest interest A2, 10800. 1 plus 8 by 100, because it's second year. Then it will be 108 100 into 108 upon 100, 108 upon 100. So we will multiply it. What will get? After multiplication, we will get 12597. Clear? This is A3. Because in the same way, we can say directly compound interest comes on power. If power and increasing, then we cannot get the same difference. So difference between A3 minus A2 not equal to A2 minus A1. Clear? So it is not an AP. Because do you know this formula? Working just as a power. If power is increasing, then value will be increased exponentially. If a thing which is increasing exponentially, we cannot say that the difference between two quantities will be the same. Okay. So next question is question 2. Here write the first four terms of the AP when the first term A and the common difference D are given as follows. Here 10. First term is given, the question number 1 and part 2. First term is 10 and difference is 10. So we should write 4 term. 10 plus 10, first term is 10, so it will be 10. 10 plus 10, 20. 20 plus 10, 30. 30 plus 10, 40. Clear? In second question, first term is minus 2. We should write minus 2. Second term is 0. Common difference is 0. Then second term will be minus 2 plus 0, minus 2. Again minus 2. Again minus 2. Clear? In third question, first term is 4 and difference is minus 3. Then 4 minus 3 will be 1. Then 1 minus 3 will be, because we are adding, so 1 minus 3 will be minus 2. Clear? Minus 2 minus 3 will be minus 5. Clear? In fourth part, first term is minus 1 and difference is 1 by 2. So minus 1 plus 1 by 2 will be minus 1 plus 1 by 2, then will be 1 by 2 and minus 1 by 2. We again add 1 by 2. In minus 1 by 2 we will get 0. Then if we add 1 by 2 here, we get 1 by 2 and so on. For fifth part, minus 1.25, it is first term. Second term will be if we add minus 0.25. Here 1.25 and 0.25, then it will give 150, because if 125 and 25 we get 1.50, which will be minus. And second term, if we add 25, then 175 minus 1.75, then minus 2.00. That is the AP. Now next question, question 3. Question 3, for the following AP, write the first term and the common difference. This is AP. So first question, the AP, so first term is 3. In second question, first term is minus 5. In third question, first term is 1 by 3. And in fourth question, first term is 0.6. Now their common difference is 1 minus 3 will be minus 2. Clear? 1 minus 3 will be minus 2, and here minus 1 minus plus 5 will be 5 minus 1 will be 4. So common difference will be 4. Now 5 by 3 minus 1 by 3, it will be 4 by 3. Here 1.7 minus 0.6, it will be 7 minus 6 will be 1. Here 1.1. That will be the common difference. Now next question. Question is 4. Which of the followings are AP? Which of the followings are AP? Find the common difference D and write 3 more terms. Clear? Here the difference between 4 minus 2, it will be 4 minus 2 is 2, 8 minus 4 will be 4. So this is not equal. This is not AP. In second, 5 by 2 minus 2, it will give 2 to the 4, 5 minus 4, 1 by 2, and 3 minus 5 by 2, 6 minus 5, 1 by 2. So the common difference are the same. So it is the AP. Okay. Now, if it is AP, then we should find out the next 3 more terms. So it will be 7 by 2. It will be 7 by 2 plus 1 by 2. 1, 2, 3, 4. This will be 5. A5. A5 will be 7 plus 1, 8. 8 by 2. 8 by 2, that means 2, 4 ja 8, 4. And A6 will be 4 plus 1 by 2. 4 2 ja 8. 8 plus 1, 9. 9 by 2. A7, 9 by 2 plus 1 by 2. 10 by 2, which will be 5. So do you know next term will be 4, 9 by 2, 5, and so on. Here we should check third part. Minus 3 dot 2 minus plus 1.2. Then what will be 2 to 0. 3 minus 1 will be 2 minus 2. And next minus 5 by 5.2 minus plus 3.2, it will be 5, 3, 2. So these are the difference same. What will be the next term? So A5 will be 7 minus 7.2 and minus 2.0. then it will be minus minus plus minus 9.0, and A6 will be minus 9.0 minus 2.0, then it will be minus 11.0, and A7 will be minus 11.0 minus 2.0. This will give minus 13.0. Clear? Now there is any mistake? Minus because we know the answer 1.2, 3.2, 5.2, 7.2, it will be 9.2 and 11.2 and 13.2, minus minus minus. So 3 minus 3.2 plus 1.2, it will be 2, 3 minus 1, 2. We should add 2.0, so we get 2. We get 2. Okay. Now here there is one question missing. 10, 6, 10, 6, 6 minus 10 minus minus plus 6 minus 6 minus 6 plus 10, it will be 4. The difference is 4 and the difference is 4. So here 4 is adding 2 plus 4, 6, 6 plus 4, 10, 10 plus 4, 14. That will be the answer. Now we will write directly 3 plus 2, 3 plus root 2, then there is a difference root 2, 2 root 2 minus root 2, there is difference root 2, and there is a difference root 2. So next term will be 3 plus 3 root 2 plus root 2, then it will be 3 plus 4 root 2. 3 plus 5 root 2 and 3 plus 6 root 2. Now 0.2, 0.22, these are not the same because number is increasing exponentially, so difference will be increasing. The difference between first and second term, here 0.02, then 0.002, which is increasing, so it is not AB. In 0 minus 4 minus 8, that means minus 4 is minus 4 is the common difference, so number will be minus 12 minus 4 will be minus 16 minus 20 minus 24. Minus 1 by 2 minus 1 by 2, the constant term, so again it will be minus 1 by 2 minus 1 by 2 and minus 1 by 2. That is the now 1, 3, 9, 27. 3 minus 1, 4, 9 minus 3, 6, so 4, 6, so these are not an AP. Clear? Now 2a minus a, here a 3a minus 2a, so it is in AP, and here will be 5a, 6a, 7a. Now the difference between a square minus a, because this is not a directly, because it is exponentially, so exponential series never will be AP. A square minus a and aq minus a square, if we take a square here, a into a minus 1, then a square a minus 1, so it is not an AP. Root 2 root 8, it is also exponentially, but we should rearrange it. Root 2 root 8, we can write 2 4 ja 8, so 2 root 2 we can write, and root 18 we can write 3 9 2 ja 18, and 3 root 2, so 32 root 16 2 ja 30, 4 root 2, here 1 root 2. So next term will be 5 root 2, 6 root 2, and 7 root 2. That will be. Now root 3 root 6 root 9 root 12, here first term is for 30 number, first term is root 3, second term is root 6, then root 2, there will be no factor, which will be common. Root 9, it will be 3, root 12, 2 root 3, and so the difference between this, if we take common root 3, it will be 1 minus root 2 minus 1. Here there is no difference, which is same, so it is not an AP. Here 3 square minus 1, 3 is 9, 9 minus 1, we cannot get the same because it is exponential, so it is not AP. Here no exponential, we should check it. 1, 25, 49, 73, then 25 minus 1 will be 4, and 49 minus 9, 4, and 4 minus 2, 24, so it is increasing, so it is not an AP. Here we will find out what is nth term of AP. Do you know, if you observe, we write number A, then A plus D. If we get A plus D, then we will get A plus 2D, A plus 3D. This is A1, this is A2, this is A3, this is A4, and so on. If here 1, here 0, here 2, here 1, here 3, here 2, here 4, here 3. So if here is an, then here will be n minus 1 into d. Clear? This is nth term of a. Here first term is a, common difference is d, a plus d, we can write a plus 2 minus 1, a plus 2d, a plus 3 minus 1d, so a plus n minus 1d, a plus n minus, this is the, but we will solve exercise 5.2 in next video, so please wait and watch for our upcoming videos, which will be very helpful for you. So we look forward to connecting with you in our upcoming videos. So wait and watch. Thank you guys. Thank you my dear friend.